What up, Geo? Let's go through here and figure out now surface area. All right, we're just going through, we're going back over the stuff that we did yesterday with surface area, except for we have a hexagonal prism or a regular polygon-shaped base. How do we go through and do that? It's the same as yesterday, and then we'll get into some cylinder stuff, okay? So right now, finding that surface area, remember, we want to break it down into nets, and then find the area of each piece, add them together. So if I unfolded this or talked about the faces of this hexagon, I would have two bases, all right? They'd be the front side and the back side here. You got to find the area of those, right? And then since my base has 6 sides, I'm going to have 6 rectangles that will be connecting, all right, each of these different rectangles. There's going to be 6 of them. Well, the good thing is since my base has all the same size, these 6 rectangles are going to be exactly the same length, even though my drawing is pretty poor and they are not the same length, okay? They're all going to be the same. So what we have to do is find the area of a regular polygon. Remember from Unit 2, the test that we just took, or the last test we just took, the formula was area, or apothem times the perimeter divided by 2. All right, well, I know the apothem, it gives us in the directions, since we, again, when we get to trig and stuff like that later on, right triangle math, we'll be able to find the apothem ourselves. A is equal to 4. Perimeter is equal to 6 sides, all 5 units in length, which is 30. So 4 times 30 divided by 2. 4 times 30 is 120. 120 divided by 2 is 60. So I know the area of this guy is 60. I know the area of this guy is 60 as well. And then now we have to find out the area of each of these rectangles. Well, I know the short side is 5, right? And that's coming from this side right here. That's 5. And the long side is 10. So each of these are going to have an area of 50. 5 times 10 is 50. And again, since there are 6 sides to my base, I'm going to have 6 of these rectangles. So now I'm just going to go and add all those up, 60 plus 60 plus, and then I'm just going to do 6 times 50 because I know there are 6 rectangles with 50. So then my area or surface area, total combined surface area is 420. We don't have units of measure, so we'll say units squared. All right. Why don't you guys go ahead? You guys try problem number, I guess this would be problem number 2 out. Again, it's a regular hexagonal prism, so it's got a base that has 6 sides. The height's 16. And remember, that's the value that connects the 2 bases. So right now, it's not sitting on its base. So this length here, any of these lengths here would be the one that's considered 16. And the apothem they give us is 7. So go ahead, you try that out. Pause the video. All right. Well, let's go through this now, right? I have that as my base. I have 2 of those guys. Apothem times perimeter divided by 2. All right, so side length of 10. My perimeter is 6 times 10, or 60. And my apothem is 7, so I'm going to do 7 times 60 divided by 2. 7 times 60 is 420. 420 cut in half gives us a grand total of 210. So each of these hexagons has an area of 210 square inches. All right? Now, for what we call the lateral area, lateral surface area is these are the non-bases. Add up all those areas, that would be the lateral area. We're not too worried about that. We're just really looking for total area. In each of those rectangles is 10 by 16 or 160. So I'm going to do 210 plus 210 plus 6 of these that are 160 units long. I'm going to add both of those, or all 3 of those together, and we're going to get a grand total of 1,000 380 square inches for all of those pieces added up, the 6 rectangles and the 2 bases. All right. The base of a regular hexagon has a length of 10 and the prism has a height of 16. Find the surface area. That appears to be the same exact question, so we will not worry about that. You can make up your own problem, put in your own apothem and knock your socks off. Enjoy that. All right. So here's the second part today. We're going to go through and talk about cylinders. All right. Can of soup. How much tin would it cost, or how much tin would it make to make a can of soup? All right, so we are finding the area of the bases, right? We have 2 bases. We're going to be finding the area of circles. And then if I cut, right, if you think of that wrapper that would be on the soup label or those Powerade bottles and Gatorade bottles, it is a rectangle. Okay, so this is our 2 shapes when we have it broken down. These are our basically 3 shapes. We have 1 rectangle and then the 2 circles that are the 2 bases. We're going to find all 3 of those, add them together. Now the good thing with our cylinder is we have this formula. These represent the bases, and this is the dimension of our rectangle, right? How did we get that dimension? Well, this would be considered the height, that's h, and this bottom piece, or the top piece length, wraps around the entire circle, right? Would wrap around this entire circle. So the distance around the circle is just the circumference, and that's 2 times pi times r. So that's where in our formula we get 2 pi r times h. That's just the area of that rectangle, okay? And since that's wrapping around, we have our 2 bases on the top and bottom, and that's wrapping around, we call that a lateral surface area, the side of the shape that we're talking about, the non-bases, okay? So if we want to fill this in, we got 2 parts. We got the base, we got the height, and then we got the, I guess the rounded piece we would call the lateral area. But we can call that a rectangle if you like, because that's what it is when we unwrap it, right? So that's what we're going to be doing. Now this oblique thing, it's just like when we talked about parallelograms, right? When we want to use the height of a parallelogram, it's not this far right side length. It is the one that's straight up and down, making that 90-degree angle. So if we have a slanted or what we call oblique cylinder, this value right here would not be considered our height anymore. We want the height to be the one that's straight up and down. All right, so let's apply this formula to what we got. Okay, we have a cylinder, 5 centimeters is the radius, 10 centimeters is the height. Well, I have 2 bases. They're both circles. We know both of those are pi r squared. So we're going to do 5 squared times pi, which is 25 pi. This guy over here is also going to be 25 pi. And now we have to find the area of our lateral piece. I'm just going to draw that in blue, or highlight it in blue. Okay, this is going to be 10 times, again, the distance around here, unwrapped, is going to be this distance here, which is our, what we call the circumference, which is 2 pi r, or diameter times pi. So I'm going to take 5, multiply it by 2, multiply it by pi, and that's 10 pi. The circumference is 10 pi. Now when I find the area of my rectangle, I do 10 times 10 pi, which is 100 pi. Now I'm going to take my 2 circle bases, add them together, plus the area of my rectangle, which is 100 pi, and we get a grand total of 150 pi, or 150 times 3.14 gives us a grand total of 471 square centimeters. All right. One thing to note, if you found out the area was 25 times pi, or 3.14. 78.5, 78, if you're approximating right away, then your decimal might be a little off from what we got at the end, or if you're using the pi button in your calculator, that's using more decimals of pi, which technically would be a little bit more accurate. I like to just leave everything in terms of pi, so I'm not looking at any of these decimals or fraction, anything like that. It's just nice numbers that I can add together. We can treat pi like a variable and do 25 plus 25 plus 100 to get 150 pi, and then multiply it out at the end. Okay, I'm good with either way. You'll have to talk with Ms. Tesh or Ms. Dedeker, see what they're expecting you to do for your answer. All right, and if it said exact answer, that's exact, because pi is irrational. That decimal goes on forever. This would be approximate. Right? All right. Uh-oh, it's doing that again. Hold on one second. For whatever reason, it likes to do that to me and not let me write on things. All right, so here we go. You guys try this out. Just be careful. 10 is not. Have a good night. 10 is the diameter. We want the radius, right? So cut that in half. We're going to do 5 squared times pi, which again is 25 pi. So we got 2 circles that are 25 pi. And then we're going to do our rectangle. Our height is 100 this time. And again, the distance around is the distance on the top here, and that's the circumference of the circle, which is diameter times pi, so that's 10 pi. This is basically the same type of problem. Well, it is the same type of problem, but they're very similar numbers, so everything's going to look and feel the same. So this is going to be 1,000 pi, 1,050 pi when I add 25 pi, plus 25 pi, plus 1,000 pi. And then when I multiply that out by 3.14, we're going to get 3,297 square feet. All right, last one. Why don't you guys try this one out? Pause that video, try it out. All right, well, here we go. Pi r squared. Area of the one triangle is one circle is 100. So that means the base is also going to be on the bottom is 100. So both of these are 100 pi. Now we have to unwrap our rectangle. The height is 25. And again, the distance around here is the distance on top when it's unwrapped like it is, and that's the called the circumference. That's diameter times pi. The radius is 10. Double that to get 20. Multiply 20 and 25 together, we get 500, or 500 pi. And now take our 3 parts, the 2 circles plus the rectangle, add them together, we get 700 pi, or 3.14, which is 2,198, and we're in centimeters, so squared centimeters. So good luck. Remember, when we're going through circles, that the hardest part to see is that this the circumference of the circle is going to be the length of our rectangle that we have. Okay, good luck. Let us know if you guys have any questions. And again, when we have our prisms, the bases are identical. If it's a hexagon or a pentagon, our formula is the apothem times perimeter divided by 2. All right, have a good night.